All right. Today we're doing a deep dive into the real backbone of television networks. We're looking at a very specific piece of hardware. It's the Thor Broadcast H-4ATSC-QAM-IPLL transmodulator.
Which is a mouthful, I know.
It is. But at its core, it's like a universal translator. Our mission here is to figure out why this four-input box is so essential for anyone running a modern head-end or, say, a big MATV system.
Right, and it's probably good to define head-end first. I mean, think of it as the brain, the central hub where a cable company pulls in all its signals, processes them, and then sends them out to you.
The ultimate control room.
Exactly, and an MATV system is just a smaller version of that, like for a hotel or a hospital. So this device, which, it costs about $2,500, its whole job is to solve signal chaos.
Okay, so that sets the stage perfectly.
Yeah.
It's all about dealing with a messy mix of inputs. So how flexible are we talking? What can this thing actually handle?
You're talking total flexibility. It'll take pretty much anything you throw at it.
Yeah.
So satellite signals, DVB-S, and S2. It takes over-the-air terrestrial signals, like ATSC.
What most of us get with an antenna.
Yep. And it takes existing cable signals, which is QAM, plus it has 2 ASI inputs for other digital streams. And what makes this really pro-grade is that you often swap these input types with physical hardware modules, not just a software update.
So it's a hardware change, which points to reliability.
It's built like a tank for that reason.
You see these specs on the inputs, and they really tell a story. For instance, it says the ATSC input supports 8 VSB and has an MER of 42. Now, why should an operator care about a number like 42?
MER, the modulation error ratio, is basically a grade for signal purity, an A+. In a head-end, which is a very noisy place electronically, getting a 42 is it's exceptional. It means the signal is super robust.
So fewer glitches, fewer angry calls from viewers.
Precisely. It means higher uptime.
Okay. But a lot of these signals aren't free, right? They're encrypted. Let's talk about security.
Absolutely. The box has 4 common interface slots, or CI slots. Think of them as 4 security gates. You slide in what's called a CAM module, maybe a cable card, which some people might recognize, and that decrypts the stream before it goes any further.
So now we have 4 clean, decrypted signals. This is where the real magic happens, right? How does it blend all of that into one unified stream for everyone to watch?
This is where the device, earns its keep. It's called multiplexing. But it's not just stacking channels. It's managing all the tiny data streams inside each channel. It handles something called PID remapping, and it can do 128 of them for every single input.
Whoa, okay, 128 PIDs. Let's pause there. For anyone listening, what is a PID, and why on earth does managing 128 of them matter?
A PID is a packet identifier. It's a unique digital tag for everything in the channel. The video, the main audio, the Spanish audio, the closed captions, all of it. If you map even one of those 128 tags incorrectly after you decrypt and remodulate, the channel just breaks.
You get a black screen, or maybe no sound.
Exactly. It's the difference between a working channel and a dead one.
And it's not just about getting the streams right. There has to be a timing element to keep it all from falling apart.
That's the other critical piece. It's called PCR adjusting, program clock reference. The PCR is the heartbeat that keeps all those 128 PIDs perfectly synchronized. If that clock drifts even a little, you get stuttering video or your audio goes out of sync.
Wow, and it's doing this across signals that started out completely different.
Right, one from a satellite, one from an antenna. It has to create one perfectly timed, unified beat for all of them.
So once it's all synced up, how does it deliver the final package over a network?
It pushes out 9 IT streams. You get 8 single channels, what we call SPTS, and then one big stream with the whole bundle, an MPTS. And it uses standard protocols, UDP, RTP, so it's compatible with everything. And of course, it passes through all the accessibility stuff, closed captions, Dolby audio, all of that.
So when you boil it all down, this transmodulator is really the unsung hero, the brain of the operation. It takes complete chaos from the airwaves and satellites, performs this incredible high-precision digital alchemy, and then outputs a single perfect stream.
It really is, and it makes you think when you consider the millions of calculations happening every second just to keep one channel's 128 PIDs and its PCR clock perfectly aligned, what kind of invisible precision is required just to make sure that when you flip to a channel on your TV, it just works. The level of hidden complexity is just fascinating.